So the last time we were together, we graphed two functions, sine and cosine, that look just like this, okay? So we're building as we go along. What does the A represent here? There's a word, amplitude, okay? So the A represents the amplitude. What is the amplitude of a sine or cosine graph? Graphically, what does it look like on the graph? If the amplitude is 2 versus the amplitude of 4, what does that mean? It goes up. So like from 0, amplitude of 2 goes up to 2 and down to negative 2. Okay, amplitude of 4 goes up to 4, down to negative 4. And then B, we use this to calculate the what of this graph? The period. Okay, so we know that the period is 2 pi over B. So technically the amplitude is the absolute value of A, and this is absolute value of B. They're all positive. Okay, and so this is the same for sine and cosine. So for example, if I had f of x equal negative 3 sine 1/2 x, what is the amplitude of that curve? Yeah, the amplitude is 3, and the period is what? It's 2 pi divided by 1/2, and that number is 4 pi. Okay, so the period tells me how far the graph has to go before it starts to repeat. Okay, so let's do a couple examples. So the only other thing that we added to this was, what does the negative in front of the curve do? Yeah, it reflects it. Okay, so what is the amplitude of this? 1. Okay, what's the period? You know, it always helps. It's just 2 pi over whatever number is in front of x. So it's 2 pi over 1/2. That number is 4 pi. Has this been reflected about the x-axis? Yes. Okay. So using that information, I can graph this. This is where I start at 0. And then what do? Go over what? 4 spaces. 1, 2, 3, 4, and label that what? That's 4 pi. Okay, but I'm going to graph one complete period of this graph. So what's exactly in the middle here? 2 pi, which makes this pi, and 3 pi. And then with an amplitude of 1, my graph is going to go up to 1 and down to negative 1. Okay. So cosine normally starts at 1, right? What happens when the 1 is multiplied by a negative 1? That means it's going to start where? Negative 1. If it starts there, where is it going to end? Same spot, okay? This is one complete period, okay? Normally the cosine would start at 1, but with the negative, it's going to start at negative 1. Now, normally halfway in between, the cosine is at negative 1. What happens when the negative 1 is multiplied by negative 1? 1, okay? And then what happens at these points halfway in between? What is it? 0 here and 0 here. So this is, so that's what the curve looks like. Okay? So again, it's helpful to know how you draw sine and cosine. You know, they're different in terms of how we describe the drawing of the graph. But all the graphs are going to look the same. What's going to be different is how it's labeled. Normally the period is 2 pi. This one got stretched out. So it's 4 pi before it makes a repeat of the cycle. Let's take a look then at the next one. What is the amplitude here? 2. What is the period? It's 2 pi divided by 4, which is what? Yeah, 1/2 pi, pi over 2, same thing. Has it been reflected about the x-axis? That would be no. Okay. So in order to graph this, this is 0. I count out 4 spaces and label this what? That's pi over 2. Okay. Now, what is half of pi over 2? Pi over 4. So that's right here. What's half of that? Pi over 8. Noah's on fire back there. So if this is 1/8, 2/8, what's this one? This is 3/8 pi. And that's 4/8 right there. So what does the sine function do? Where does it start? Starts at 0. Where does it end? Halfway in between. 0. Okay. Normally the sine function will go up to what value? Yeah, normally it goes up to 1, but when it's multiplied by 2, it goes up to 2. Okay. Normally here it goes down to 1, but this is going to go down to -2 because it's multiplied by 2. So this curve is this. So that's, and then label this as what? -2. So you want to make sure you've labeled the x and y axis accordingly, so I know exactly this went up to 2, it went down to -2. Okay. So same procedure. This is what we've been going through so far with all of these graphs. Now we're going to add one more element to how we graph these guys. So what's the difference here? What do you think that does to a graph? Adding something to a graph, what do you think it does? It shifts it where? It's going to be up or down. These were the easier shift. Remember, left or right is the one we have to think about. So if k is positive, it's going to shift the curve where? Up. If k is negative, it shifts the graph down. Okay? So again, absolute value of A is my amplitude. And I know that 2 pi over the absolute value of B, that is my period for the graph. And then K just represents a vertical shift. So basically it takes the whole curve and moves it up or down. So this just adds one more element to our graphs. Okay. So let's look at the next one here. So amplitude, the only thing that affects the amplitude is what's right in front of the sign. So the -1 over here doesn't affect it. So what's the amplitude here? 1. What's the period? Period is, it's 2 pi divided by what's in front of x. Right? Which is what? Just 2 pi. So the period is 2 pi. Has it been reflected about the x-axis? No. And, pardon me? It would be a negative in front here. Okay? And vertical shift, it looks like there's a vertical shift of -1. So here's what we're going to do. To graph this guy, the first thing I'm going to do, this is -1. I'm just going to draw a line at -1. Okay. So what I'm going to do, and then I'm just going to graph the function. So I'm going to shift the entire graph down. So instead of graphing it here at 0, I'm going to graph it at -1. Okay. So I just need to label these points. What is the period? Yeah. So this is 0. 1, 2, 3, 4. This is 2 pi. That makes this pi. This is pi over 2. And this is 3/2 pi. Those are the points. Okay. But instead of graphing it up here, I'm just going to graph it on the red line. I'm moving it down 1. So sine function starts where? Well, it starts at 0. Okay, so I've just basically moved my x-axis down. So normally it starts at 0, it ends at 0. Halfway in between is 0. With an amplitude of 1, it's going to go up how much? 1. So I'm going to, from the red line, I go up 1, and from the red line I go down 1. Okay, and so now what you see is this curve right here. This is why that description of how you graph them is helpful, because now, you know, I didn't technically graph it at 0, it's at -1, but I've got that description of, let's pretend that red line is now my 0 axis. So let's just graph the sine function. So all the functions, all these graphs look the same, it's just that they're moved around. So this is the same as sine of x, which would be graphed right here, but it's just all been moved down 1. Okay, so the most helpful thing to do here is to graph that vertical shift at the very first. So looking at this one, what is the amplitude? Yeah, the amplitude is 1. Period is, it's 2 pi divided by 1, which is just 2 pi. Okay. Has it been reflected? No. There's a vertical shift of what? Yeah, plus 2. Okay, so what I will do in this one, if this is 0, 1, 2, 3, so I'm going to draw a line at y equal 2. So right here, I'm just going to draw a line, and I'm going to proceed with graphing my curve from that being my axis. Okay, so remember then this is 0, 1, 2, 3, 4. That's the end of the period. That's 2 pi. That makes this pi, pi over 2, and 3/2 pi. But instead of graphing right here, I'm going to graph up on the red line. So cosine, where does cosine start? Cosine starts at, am I not hearing the word 1? Cosine starts at 1, okay? So, but from here, where do I find 1? Where do I go to find 1? Where? No. So what I've done is, instead of graphing it here, I've shifted this up, okay? So normally I would go up to 1. If this is now my baseline, what happens when I go up 1? I go there, okay? So it's going to, so I look at this as my axis. Normally the cosine starts at 1, it ends at what? 1. Halfway in between, it's where? -1, okay? And then halfway between these 2 points is what? 0. And halfway between these 2 points is 0. So what this looks like is this curve. So it's a cosine graph that should be shifted up 2, okay? So that's why that description of starts at 1, ends at 1, -1, if this is where 0 is, 1 is at 3. You know, here 1 is at 1, -1 is at 1, and 1 is at 3. So 1 from where you're graphing, okay? Let's look at the next one then. What is our amplitude here? 2. Our period. 2 pi divided by 2, which is pi. Okay. Has it been reflected about the x-axis? No. Vertical shift of -1. Okay. So I'll go ahead and say if this is 0, 1, 2, 3, -1, -2, -3, I'm going to draw a horizontal line where? Yeah, at -1. And that's where I'm going to do my graphing, okay? So the period is pi. So that means that this is 0, 1, 2, 3, 4. That's pi right there. What's halfway in the middle? Wait, did I do this right? Let's see. 1. Yeah. What is halfway? Pi over 2. And this is pi over 4. And so that's 1/4, 2/4. This is 3/4, and that's 4/4. So the sine function starts where? What value starts a sine graph? Am I hearing 0? So it starts at 0. This is where my axis is. It ends at where? 0. Halfway in between is 0. Okay. Normally it goes up 1. What happens when the amplitude is 2? It goes up 2. So it goes up 2, and then here it goes down 2. So that's 2 sine 2x minus 1, okay? So again, the graphs all look the same, you know, sine or cosine. It's just now the period changes, and that's sort of like an accordion effect. It stretches the graph out or pushes back together, and now we're just moving them up or down, okay? So you want to treat that vertical shift as like you've moved the axis in order to graph this. Okay, amplitude here. Amplitude is 2, period. Yeah, so 2 pi over 1/2, and what is that? Yeah, 4 pi. And has it been reflected? No. And vertical shift, -2, okay? So in order to graph this, we've got, this is 0, 1, 2, 3. I'm going to draw a vertical line where? Excuse me, horizontal line where? At -2. And that's going to be my axis that I graph this on. So the period, Malcolm's here, so the period is 4 pi. So 1, 2, 3, 4. That's 4 pi. That makes this 2 pi, pi, and 3 pi. So cosine. A cosine normally starts where? Where does a cosine graph normally start? Nope. It normally starts at 1. So normally I would be graphing 1 above this red line, but it's been multiplied by 2. So how far up will I go? 2, okay? Normally it ends at 1, but if I multiply that by 2, it's going to go up 2 spaces. Now halfway in the middle, normally it goes down 1, but when I multiply by that 2, it's going to go down 2 spaces at, and this is what, -4? And then halfway in between, it's where? 0. So here and here. So then I'm able to graph it, and it's going to keep on doing that. So the curve is just going to keep on doing that particular pattern. Let's look and see. I don't think everyone I've had so far doesn't have a reflection. Let's see, that one has a, yeah, we've got a couple at the end. Let's just do another one with a reflection here. Let's just change this one to have a reflection, okay? What is the amplitude of this one? Amplitude is 1. What is the period? Pi. Has it been reflected? Yes. And vertical shift of 3, okay? So to graph this, this is 0, 1, 2, 3, 4. So I'm going to draw a horizontal line at 3, right here. So the period is pi, so that makes this 0. 1, 2, 3, 4. That's pi. What's halfway in the middle? Yeah, pi over 2. That makes this pi over 4. And that makes this 3/4 pi. So normally the sine function starts out at what value? 0. Okay, so the sine function starts out at 0. Where does it end? What is it halfway in the middle? 0. Okay. Now normally the sine function goes up 1, right? What happens when it's multiplied by a negative? Instead of going up 1, it does what? It goes down 1. Okay. Normally at this point the sine function goes down 1. What happens when that's multiplied by a -1? Yeah, it goes up 1. So it does this. So we see this behavior. So that's the inverted sine function reflected about the x-axis. Okay, let's take a look at a couple more, and then you'll have time to do some of these on your own. What is the amplitude here? Yeah, amplitude is 1. Period, 2 pi. Reflection, yes. Vertical shift, up 1. Okay, so to label my axis, 0, 1, 2, 3. The first few graphs I was starting right here. It's okay. I mean, it's okay to start it here. It doesn't bunch things up. So the period is 2 pi. So we'll call this 0. 1, 2, 3, 4. That's 2 pi. That makes this pi, pi over 2, and that makes this 3/2 pi. A cosine function. Where does a cosine? Well, let's see. No, and I need to graph the horizontal line where? At 1. Okay. Cosine function normally starts out where? Starts out at 1. So that would mean starting out here, but if it's multiplied by a negative, that would be where? Right, down 1, okay. And then if it starts here, it's going to have to end here. Halfway in between, normally the cosine is -1 below. What happens when that is multiplied by a negative? It's going to be 1 above, okay. And then halfway between these 2 points on a cosine is always a 0. So what this graph does is this. Okay, so all we've added is just this vertical shift element. So graphically, you draw that horizontal line first, and then you treat this like it's the axis. Okay, then you do everything we've done before in graphing these. Okay, the last one, then I'll turn you loose to do your own. What is the amplitude here? Amplitude is 2. What is the period? Yeah, 2 pi over 1/4. What is that number? Yeah, 8 pi. Has it been reflected about the x-axis? Yes, vertical shift plus 2. So 0, 1, 2, 3. I'm going to draw a horizontal line at 2. And the period is what, 8 pi? So if this is 0, 1, 2, 3, 4, that is 8 pi right there. What's in the middle? 4 pi, 2 pi, and 6 pi. So a sine function. A sine function normally starts where? At zeros. And it ends at what? Halfway in between. Okay. Those are nice because those points don't move. Now normally the sine function will go up by 1 unit. Okay. What happens instead of going up by 1, it's multiplied by -2. It's going to do what? Go down 2. So it's going to go down 2. Okay. Normally here it goes down 1. So what happens when a -1 is multiplied by a -2? It goes up 2. So this point right here. So your graph is this. Okay. So again, all of these, like I said, the graphs are going to look the same. Your work is determining the period so that you know how to label properly define one complete cycle of the graph, and then taking care of the vertical shift and then the amplitude. So in summary now, we started out the day just being able to graph without the K. So all we've done is, when we look at this, A cosine bx plus K, A sine x plus sine bx plus K, we use the number in front for the amplitude. The number in front of the variable helps us determine the period, and then K is the vertical shift. Okay, so the way we do it with graphing is, there's a mistake here. When we're graphing it, we graph a horizontal line at whatever the value K is, basically shifting the axis, and then we just graph from there. Okay? Alrighty, so you guys have time to go ahead and get started on the homework, which is 8.3. And then, like I said, tomorrow is Experience the Arts, so we're not going to do a lesson. I'll check this homework then when I see you guys on Thursday. Yes. No. Did Sultan tell you that?